Hey, students, anyone here? Okay, so let's start our lesson. Okay, so do you receive any information about your face-to-face class? Anybody?
Well, so far it's only virtual.
They just informed you virtual,
Yeah. Even
Okay.
even the Thursday practicals are virtual. Technically, yeah, virtual.
For the time being, I think the government decided to open up, so we are just waiting for the emails from the higher management.
Yeah.
Once we receive the the email, I think soon you'll get the information. So is it going to be face-to-face? Okay. So we done with topic 5. We are doing topic 6. Okay. So I supposed to give you one extra class, the replacement, but I don't want to disturb during holiday. So I think we put it in coming week. Okay, so we are halfway of doing this topic 6, oscillation. Hope you still remember what we done about this topic. Okay, so let's continue from this topic. So A2 overall, how many topics you have? A2 you have about 16 topics. You have 16 topics. Out of 16 topics, we are at the 6th. So we need to cover around another 10, excluding oscillation. Okay. So oscillation, let's recall back. We've done about simple harmonic motion. You can see the notes, right, everyone?
Yes.
Yeah. So we're done with the first part, simple harmonic motion. So what is meant by oscillation? It has a back and forth movement. We talk about a period, frequency, displacement, amplitude, and phase, same as wave. Then we talk about something called a unique oscillation called simple harmonic motion. What is simple harmonic motion? It's a type of oscillation where the acceleration is proportional to displacement but directed in opposite direction. Okay. So then we start derive formula for 3 quantities. What 3 quantities? We derive for displacement, velocity, and acceleration. Okay. So x equals to x naught sine omega t, the one given here on top here. This is a formula for what? This is the formula for displacement when the time starts where? At the equilibrium. Okay, at the equilibrium. Okay, guys, I think some of you need to off the mic because it's all shut down. Okay, good. Now it's better. Okay, so x equals to x naught sine omega t. This is your displacement equation. When the time starts where? The time starts at the center. Okay, x equals to x naught sine omega t. Then you see here, from here, the second equation, x equals to x naught sine omega t. Then we differentiate with respect to time. The V formula is formed. So what we write in D here is dx over dt. Dx over dt. We differentiate the displacement. We got velocity formula. The omega V naught is actually what? Omega x naught. V naught is actually omega x naught. Okay, omega x naught. Okay, so that's then later we derive acceleration. Acceleration is what? We do dv dt. Okay, we do dv dt. Then we get the, what is the formula? Negative omega squared x naught cos, sorry, not cos, sine omega t. Okay, not cos, you got sine omega t. You got sine omega t. Okay, so this is the formula for acceleration. Okay, so go back to the PowerPoint. Okay, so PowerPoint, we done the front part. The phase, so simple harmonic motion, acceleration is directly proportional to the displacement, but in opposite direction. The graph we traced out, acceleration of x is a negative gradient. Okay, then I show you this animation that first arrow and the third arrow always is in opposite direction, defining SHM. Then x equals x naught sine omega t. Then v naught cos omega t. V is omega x naught. Then A is we got negative omega x naught sine omega t. We just do differentiation of the velocity. Okay, and the acceleration graph going to be a negative sine graph. Okay, displacement is a sine graph. The velocity is a cos graph, and the acceleration will be opposite of displacement, negative sign. Okay. Okay. So now this is the 3 type of graphs for the first version. Okay. Okay. For second version, I told you if the time start at the age. Okay, let me show you. If the pendulum start at the age, then x will be what? X naught cos omega t. So the graph going to be a cos graph. Then velocity will be what? Differentiate this. We got omega x naught sine omega t, negative. So it's going to be a negative sine graph for velocity, v versus time. Then third acceleration, we do what? We do dv dt. So you get negative omega squared x naught cos omega t. So you get the third graph for acceleration, which is going to be a negative cos. So it's going to be a negative cos. Okay, negative cos. Okay. So these are the 3 graphs for the side. Okay. So now you already achieve a situation where you can find displacement, velocity, and acceleration at any time, at any given time. Okay. Okay. Now what we're going to do is we want to find the velocity and acceleration at given displacement. Now displacement. We know v in terms of time, v in terms of t as a function. Okay. The omega x naught cos omega t is in terms of t as a function. You tell any time, you get the velocity. But now we want to find velocity at given displacement. That means something is oscillating. Let's say its amplitude is x naught is 5 centimeter. They can ask question like when the pendulum is like displacement of 2 centimeter, when x is 2 centimeter, somewhere here, a 2 centimeter way in the diagram, okay, at this position, what is its velocity? They can ask what is its velocity at a given displacement. So when they ask velocity at given displacement, you can't use this formula, the Vt formula, the V in terms of time as a function, because this is input is the time. You tell time, anytime, it gives you velocity. But now they give displacement, you can't use this formula. Okay, so what do you have to do? Now we need to derive formula for V in terms of X. Okay, so that's our today's lesson. Then they can ask question about what is the acceleration at a given displacement also. Okay, what is the acceleration at a given displacement? Okay, these are the 2 things they're going to ask. Okay. Okay. So let me do on this whiteboard itself. Clear here. Okay. We use x equals to x naught sine omega t. We use the first version. At the time 0, the displacement x naught sine omega t. We want to find the velocity formula. Velocity formula in terms of time, we know already is omega x naught cos omega t. Okay. But we want to get velocity in terms of v in terms of x. Okay, in terms of x. So what we do, what we change here, what we do want here in this upper formula, we don't want the time. We don't want the time. Time need to be thrown out, replaced with displacement. Okay, so we don't want time. We want to replace the time in terms of displacement. So how do you throw out the time? You can't throw out the time alone. You have to throw out the entire trigger. You need to remove entire trigger. The cos omega t need to be replaced. Okay, so what we do? Cos omega t is what? To find cos omega t, we use the above formula here, the top formula. The top formula, x equals to x naught sine omega t. If you make sine omega t as the subject, how's the equation going to look like? X over x naught, correct? It's going to be x over x naught. So we make a triangle. We make a triangle. We make a triangle, okay, where this is your the omega t, your angle, okay. So sine omega t is x over x naught. Sine is what? Opposite over hypotenuse. Sine omega t x over x naught means in this triangle, opposite will be what? X. Okay. Hypotenuse will be what? X naught. Correct? If it's a triangle. So opposite over hypo is your sine. Can you get what will be the adjacent will be? Anyone? In terms of x and x naught, what is the adjacent value will be? Use Pythagoras theorem, get me this. What here will be? The adjacent. The hypotenuse square minus the opposite square, right? So x naught square minus x square square root will be the adjacent, correct? So anyone got problem here? If you have a triangle, like for example, you have a triangle. Here the hypotenuse is 4, the opposite is 2. What is the adjacent going to be? If it's a 90 degrees triangle, of course it's 4 squared minus the 2 squared square root, right? Same thing like here. The opposite is x, the hypotenuse is x naught. So what is the adjacent value? The opposite squared, the hypotenuse squared minus the opposite squared square root. Okay, from this triangle, can you get omega t and all? You want to find v in terms of x. So omega x naught. Anyone? What is cos omega t from this triangle? The adjacent over the hypotenuse, right? The adjacent over hypotenuse is your cos. So can you fill up here? What is cos going to represent? It's root of x naught squared minus x squared over x naught, correct? Okay. So the formula going to be modified to what? X naught cancel. It tend to become omega root of x naught square x squared. This is the formula for velocity in terms of any displacement. Okay, this is the new formula for to find velocity at any given displacement. Okay. So any questions from here? So this is the new formula you're going to use on top of the earlier one, the sine omega t, v, x, you got x, v, and a in terms of time already. Now we got a new formula, v in terms of displacement. The v in terms of displacement is this formula. The v in terms of displacement is omega root of x naught squared minus x squared. Omega is what? Angular frequency. X naught is what? Amplitude. X is what? The displacement, you want the velocity. Okay. So this formula, how do you derive? This formula is derived from we use the first version displacement. We draw the triangle for the sine. Sine is x over x naught. So you put x, x naught. So you find the adjacent by using the hypotenuse and the opposite. Then we find cos. Cos we replace with we find the cos omega 3 from the triangle. Then we get the Vx formula. Okay. So let's proceed from here. Okay. Okay, now this Vx formula, how are you going to use? Let's say I ask a question, one example. I put one example here. Let's say you have a pendulum swinging, okay, as an amplitude of 5 cm. Okay, it's swinging. I'm asking, what is the velocity of the pendulum when what is the velocity of the pendulum and the displacement is 2 centimeter? So what formula must come to your mind? This is the formula must come to your mind. So we want V at 2 centimeter. So how do you find the V? Omega root of x naught squared minus x squared. Okay, now what is your x naught will be? Anyone? X naught is the amplitude. So we put 5 squared minus x is what? The displacement you want the velocity. So in this case it's 2. So we put 2 squared. Now omega. Omega, they won't give you directly. You need to calculate. To calculate omega, what information they must tell about this oscillation? Anyone? How do you find omega? The circular motion knowledge is theta over time or 2 pi over t, or another one formula is what? 2 pi f. Any one formula. So to calculate omega, what information they must tell us about this oscillation? Normally they give you the period or the frequency. So let's say I give you the period of this pendulum is 2 seconds, quite long. So you can calculate the omega also. So how do you get the omega? Omega is 2 pi over t. So 2 pi over 2 seconds. You can calculate out the speed it's moving at that moment, meter per second. Okay. Any questions from here, this part? No questions. So what do you learn so far? You learn to find velocity at any given displacement. Formula is Vx is omega x naught squared minus x squared. To find the velocity at given displacement, they must tell you the period, just for the sake of finding the omega. They must tell you the amplitude, x naught must be given. And of course the x, they must tell which displacement you want the velocity. Okay. Okay, now the thing is, this formula was derived by using the first version, x equals to x naught sine omega t. If I use second version, x equals to x naught cos omega t, the triangle going to be the triangle. And finally, I tell you the truth, if you use for the second version, you still get the Vx formula, the same formula. If you give a try, you get the same formula. So the Vx formula is only one version. For any type of starting at the center or at the edge or at the left side, the Vx formula is standard, same. It's omega root of x naught squared minus x squared. Okay. Okay, so now, any questions, guys, from here? Need your input? No, Stop me if you have any problem. Okay, now I clear this. Okay, now the V equals to omega square root of x naught squared, x squared. Okay. How the graph will look like if you plot V versus X. Is it going to be a straight line? Is it going to be a quadratic? This is one of the weird graph ever happened in physics for your A levels. Okay, so you see we are plotting V versus X. V versus X. So mathematically, V, let's say I put it as like Y because you are used to it in maths as Y, variables Y, because V or X, Y axis, so we put it as Y. W is constant, I put a number 10, let's say. X naught also constant, I put a number 10 squared. minus x is another x variables. I put x squared. How this graph looks like? I square both sides. I remove the square root. So y squared 100 10 squared minus x squared. When you square both sides, so y squared times in, what happened? You got 10,000 minus 100 x squared. How this graph looks like if you plot y versus x? Anybody? The y got square, the x also got square. If y equals to 3x, we know it's a straight line. If y equals to 3x squared, we know it's a quadratic. If y squared equals to 3x, how the graph looks like? Also quadratic by sideways. Sideways. If y squared and x also squared, how this graph looks like? Anybody? Like to try? Anyone? Yeah.
Wait.
Y squared plus x squared. Have you learned this in your maths?
Yes.
Yeah. What shape?
Straight.
Straight line. Y squared plus x squared equals to 5.
Circle.
Circle. So it's going to be a circle.
Yes. Now I remember. Yeah.
It's going to be a circle. Okay, the only weird physics, I think the only circle graph, I think, is velocity versus displacement under SHM. It's a circle. Okay, so let's evaluate more about this. This is V in terms of displacement. The extreme point here is x naught. The lowest point here is negative x naught. The maximum point here is omega x naught, because omega x naught is V max. Okay, and the lowest is your negative omega x naught. Okay, this is your velocity graph in terms of displacement. Okay, it's going to be a circle. In exam, they might ask you to trace V versus X for SHM. How the graph looks like? It's a circle. The extreme point you have to remember. X naught, negative X naught, maximum is omega X naught, below is negative omega X naught. Okay? Okay. So now let's visualize more in depth about this graph. So just now I asked a question that there is a pendulum which has a x naught 5 centimeter. I'm asking what is its velocity at 2 centimeter. So you see from this graph, the x naught is like 5 centimeter. I'm asking what is the velocity at 2 centimeter. If I go for velocity at 2 centimeter, how many answers are there? You get one positive velocity, and go down, you have another one negative velocity. We have two answers for displacement of 2 centimeter. Why you have two answers? Because why you have two answers? When you are displaced at 2 centimeter at this moment, if the particle is on the way moving to the right, you get the positive velocity. If the particle is moving on the way to the left, then you have a negative velocity. So there are two options. Okay. So yeah, you get two answers. So every velocity at given displacement, you get two answers, because we don't know whether it's moving to the right or to the left at that displacement. There is a two choices. It might move on the way to the right or might move on the way to the left. So that's why you get two answers for velocity. Okay. Okay, so this is the interpretation for velocity at given displacement. A new formula into your into the collection. Okay. So go back to these notes. So you get the velocity formula. V equals to omega x naught plus minus root of, sorry, this is the final formula. Remember this is the final form. Okay. So V equals to plus minus omega root of x naught squared minus x squared. Okay, the velocity at given displacement, Vx. Okay. Okay, now I clear this. So x v a at a given time, you know the equation. X is x naught sine omega t. V going to be omega x naught cos omega t, and a is negative omega x naught, omega squared x naught sine omega t. Now you got the Vx is found to be from the triangle. We got omega is root of x naught squared x squared. Okay, now another one formula is left. What is that? The acceleration at a given displacement. Now the question, the pendulum just now ask you, at 2 centimeter of displacement, what is its acceleration? Just now I asked what is velocity. So this is a velocity formula to be used. If they ask what is the acceleration when it's 2 centimeter away, its amplitude is 5 cm. So we have to replace the time in the third formula here. The third formula we can't use because it's in terms of time. So ax, what you need to be replaced? We need to throw out the time. Where's the time? The sine omega t need to be replaced. We're not only replacing the time, we replace the entire trigonometry. Sine omega t. So how the equation looks like? A equals to A in terms of x is equals to negative omega squared x naught. What is sine omega t replacement? So you get it from here, first equation. What is your sine omega t in terms of x? X over x naught. So sine omega t is actually x over x naught. So you substitute inside here. So x over x naught. So acceleration in terms of displacement is x naught cancel. So it's negative omega squared x. This is another formula for acceleration in terms of displacement. Okay. If they ask what is the acceleration of the SHM at a given displacement, so A equals to negative omega squared x. I can say out of the entire derivation, this is the most important graph to remember and formula to remember. Why? This is the formula defining SHM. You see, the acceleration is directly proportional to the displacement, but in opposite direction. Negative is like opposite direction. Okay. So anyone, how this graph looks like if you plot A versus X? How the graph going to look like? So A versus X. Use y equals to mx plus c. Is it could be a straight line? A don't have power, X don't have power, omega squared is like the gradient. So yes, it's a straight line. So because it's negative, it should be a negative straight line defining SHM. Okay, where the extreme point will be what? Extreme point here will be x naught. The lowest will be what? Negative x naught. Okay, what is the gradient represents? Anyone? What is the gradient represents? So from here, y equals to mx, right? So gradient is what? Gradient is your negative omega squared. The gradient is negative omega squared. Okay. So from the gradient, I think you can work out the omega. Once you know omega, you can find period and so on. Okay. So you have two addition to the list of equation. Vx, Ax, a new formula to be included. Okay, now if any SHM question, if they ask, they want to interpret, find the displacement, velocity, acceleration at any given time, you should be able to find. If velocity and acceleration at any given displacement, you should be able to find. The information they must tell us is, they must tell us the period. If they tell you the period, they must tell you the amplitude. These two important. For any investigation of oscillation, they must tell us the period, they must tell us the amplitude. Either period or frequency, because we need to use period or frequency to work out the omega. A period not given or frequency not given, you cannot investigate that oscillation. If the amplitude not given, you can't investigate the oscillation because every equation amplitude involved, x naught. So period or frequency must be given, amplitude must be provided to investigate the oscillation. If they ask in terms of time, another one extra information they must tell us. What is the extra information they must tell us? They must tell us where it starts and the time 0. Is it starts at the center or it starts at the edge, the time 0? They must tell us if you want to find displacement, velocity, acceleration at any given time. Okay. For the case of velocity, acceleration, given displacement, you don't need to tell where it starts. Center or side, same equation going to be used. Okay. So guys, any part you don't understand? Everything is fine? Okay. So let's go to the PowerPoint. Okay. So this is the 3 time graph. So I skip this first. This is another way of finding the velocity formula. The derivation, your exam not required. You don't need to know how to derive, but you need to know how to use the formula. V equals to omega square root of x naught squared minus x squared. Okay. Then this is the formula for V. Let's skip this first. Skip. Okay, and finally, there's the acceleration formula. Acceleration formula I derived you just now, right? Okay, so one example for you guys. Come on, look at this question. 1 minute. Take 1 minute. Use the formula we derived just now. Get me the answer for this. 1 minute for you. Okay, so you got the answer for this. A particle move in a SHM in a straight line with amplitude 0.05 meter and the period is 12 seconds. Okay, as I said, this is your x naught. This is your period. Period gives us omega, 2 pi over period. Find the maximum speed. What formula to be used? Anybody? What is the maximum speed formula? Anyone? Can you remember? Haris? Haris, can you give me your maximum speed formula? What is your maximum speed formula? Your V max. Your V formula is what? V formula is omega x naught cos omega t, something like this, right? So what is your V max? Maximum velocity formula. Whatever beside the trigonometry, the omega x naught. So the V max is omega x naught. Okay. So V max is omega x naught. A max is what? Negative omega squared x naught. These are the maximum values. You have to remember. So first answer, what is the maximum speed of the system? It's omega x naught. So anyone got the answer? Calculate the omega, put the amplitude, give me the answer. So omega will be how much? Omega is 2 pi over t. So 2 pi divided by t, t is 12 seconds, times omega. Sorry, that's your omega. X naught how much? 0.05. So you times, you get your maximum speed. Whatever answer you got, what is the unit? Meter per second. It's a meter per second. Okay. Okay. That's the first answer. Maximum speed. Formula must come to your mind is omega x naught. Okay. Okay, next. So all of you calculated. So you should get this answer. The first one. V naught omega x naught. So you get 0.026 meter per second. Just omega x naught must come to your mind. Okay, so omega 2 pi over t. Okay. Okay, next. Find the maximum acceleration of the particle. So maximum acceleration, what's the formula? Negative omega squared x naught. X naught is the maximum acceleration. So negative 0.52 squared times 0.05 to get the maximum acceleration. In this case, you got negative 0.014. Okay. So let's continue. So we find maximum speed, maximum acceleration ready. Now look at the bottom. Write down the value of constant P and Q in the equation which describe its motion. Okay, this is the displacement formula. The displacement formula is exactly same as the one we derived. X equals to x naught sine omega t. But here they put a symbol. X naught was replaced with P. X naught is P lah. X naught is P. Omega t, t is there, t is there. So omega is actually in this case is your Q. Q is omega. So they're asking you to find what is P and Q and put it into the formula. What is P stands for? Whatever beside the trigger is actually your, in this case, displacement, right? So P stands for x naught, maximum amplitude, because the displacement formula. Q stands for what? Omega. So do you know x naught and omega? What is your x naught from this graph? 0.05 is the x naught. Omega is what? 2 pi over 12. So you submit into this equation. So the equation, you see the answers here. X equals to P sine Q. X equals to P sine QT. So it's analog to X equals to X naught sine omega t. So X naught we know 0.05, omega is 0.52. So the equation will be written as what? So they're asking for the P and Q, right? Write down the value of constant P and Q. So P is your X naught, Q is your omega. Okay. Good idea, Any questions from here? No questions, Okay. So this I skip. Okay, guys, come on. Another 1 minute. Look at this question. Use the formula X V A in terms of time, V and A in terms of X to do this question. Okay, 1 minute again for you.
Sir,
Yeah.
for example, if they just give 0.16 sine 3 pi t, how do we know the units? Like the distance unit.
If they never mention anything, we take it as an SI unit.
So just
So
say that
0.1.
is 0.16 units.
Yeah. So you take 0.16 meter. You take it as SI.
Even though, like, I know that C already says meters, but what if they don't say it?
Okay, this question supposed to say it. Past years, they will tell you 0.16 in meter.
Okay.
Okay, so you take it as meter. Okay, but in the real past year question, they will tell you. Okay, so this case, you take 0.16 as in meter. So what is your amplitude?
0.16.
0.16 meter. Period of the motion? How to find period of the motion?
Use omega equals to 2 pi f.
Yeah, so omega equals to 2 pi over t will be straight, you get the period, right? So omega is how much? How do you get omega from the graph?
So it's 3 over 2 hertz.
3 over 2 hertz. So yeah, omega is 3 pi, right? So omega is 3 pi, so 2 pi over t. So you can find the period. Period is 2 over 3 seconds.
It's over 3.
Yeah.
Isn't it 3 over 2?
Sorry, what I mean. Oh, 3 over 2, 3 over 2, sorry. 3 over 2 seconds.
That's t, it needs to be f.
Yeah, but they want period, right?
Yes. Oh, period. Okay. But frequency also, yes.
Okay, so once you got your period and your omega, can you find the displacement velocity acceleration at 1.5 seconds? So what formula to be used? Displacement, just straight away the one on top, right? Okay, use your calculator to calculate it out. 0.16 sine, of course, 3 pi. The time you put 1.5 seconds. Be careful, the 3 pi times 1.5 seconds will be in what unit? Will be in what unit? 3 pi times 1.5 will be what unit? It will be in radian, right? 3 pi times 1.5 is in radian because pi is radian. So be careful. When you use calculator, the sign this 4.5 pi, you must use radian mode in your calculator. Or you don't want to change to radian mode, then the 3 pi times 1.5, right, which is in radian, you change to degrees first. You know, radian change to degrees. You change the radian to degrees first. Then you use the degree mode. So all up to you. You use your calculator, come on, give a try. Those who like to try radian mode, go ahead. There's those who want to go for degree mode. Change this radian to degree first before you sign it. Unless you see you got the correct answer, I show you the next slide is the answer. So use your calculator, calculate it out.
It's 0.16 meters.
0.16 meters. So as you see, the displacement 0.16 meters. Okay. Those who got 0.16 meters, use your radian mode and your degree mode. You aware of the radian and the degree mode lah. 0.16 meter. Okay. Okay. Do the velocity and acceleration. So how do you get your velocity? What formula do you use? So the displacement you differentiate, right? You differentiate, sign you differentiate, the velocity formula is what? V equals to, sign you differentiate, you got omega x naught cos omega t. This is the formula you should use, first version. So key in all the values, the V is omega x naught cos omega t. Key in omega, key in x naught cos omega t. What's the velocity you got?
Zero.
Okay, so this one got
I got 0.
0. So all of you got 0. Yeah, so the formula must come to your mind is omega x naught cos omega t. The cos omega t is 3 pi times 1.5. So 0. Okay. So next, acceleration. So what formula to be used? So acceleration, you derive the velocity formula. So A is negative omega squared x naught sine omega t. Okay, put the formula negative omega naught x sine omega t.
Negative 4.2.
Acceleration there. So negative omega squared x naught sine omega t. So you put all the informations like this. So you got negative 14.2.
Yeah.
14.2. Okay. Okay. Next, see. see, determine its velocity at a distance of 0.1 meter. Determine its velocity at a distance of 0.1 meter from its equilibrium. So what formula to be used? So Vx equals to omega root of x naught squared x squared. Okay, this is the formula to be used. And because velocity at a given displacement, you know. Okay. So key in this value. So what's the answer you got?
1.18 ms-1.
So 1.18. You must put plus minus. Okay. So those who got these answers, good. Okay, students. So this is the lessons today. Okay, I see you tomorrow. So recall back. We start slowly. Okay, we try to finish this topic as soon as possible. I plan to give you an exam next week. Next week, Monday. The topics to be included is the first 5 topics: circular motion, gravitation, temperature, idle gas, and thermal property. Okay, next week, Monday. Okay, but see first lah. Prepare. Okay, I'll give you a test through online. So I post it on the times. Then you just do it. Then you post it into the. Okay, the first 5 topics. Okay, any questions? Okay, students, I stop here. So I see you tomorrow. Bye.